You had one job walking into that room, and it's gone. Not misplaced, not fuzzy. Gone, the way a word disappears the second before it reaches your tongue. That's not your memory failing you. That's a system built to wipe old information the instant your surroundings change because, in the world it evolved for, a new room could mean a new threat. And by the end of this, you'll understand exactly why your brain decided your grocery list wasn't worth keeping. It happens the same way almost every time. You're in the bedroom, you decide you need something from the kitchen, you stand up with total clarity about what that something is, you cross the hallway, you reach the kitchen counter, and the reason is simply not there anymore. You stand in the middle of the room, patting your own pockets for a thought that used to exist. This happens to 19-year-olds with sharp memories for phone numbers they haven't dialed in a decade. It happens to 70-year-olds who can still recite the order of every house they've ever lived in. It is not about age. It is not about being distracted. Something very specific happens the moment you cross a threshold, and it is happening to you on a schedule you have never noticed. It also doesn't care how important the thought was. You can lose the reason you walked into a room with the same ease, whether the thought was, grab my keys, or something closer to call the dentist before the office closes. The system isn't grading your thoughts for value on the way through the door. It's clearing a shelf on a fixed schedule, and it doesn't stop to check what's sitting on the shelf first. Here's what we actually know. Your brain does not experience your day as one unbroken recording. It experiences it as a stack of separate files. Psychologists call each one an event model, a temporary mental folder containing where you are, what you're doing, what you're holding, and why. As long as you stay inside that folder, everything in it stays close to the surface. The moment you leave it, the folder starts closing, whether you were finished with it or not. And the trigger for closing that folder isn't time. It isn't tiredness. It's the boundary itself. In the early 2000s, a psychology professor at the University of Notre Dame named Gabriel Radvansky noticed something strange showing up again and again in his lab. In study after study, over a research career that would eventually span more than 2 decades on this exact question. He had people navigate through simple virtual buildings, picking objects up off tables in one room and carrying them into another, then quizzing them at random on what exactly they were holding. He varied the distance, he varied the room size. Nothing about the physical layout changed the pattern. What changed the pattern was a doorway. People who carried an object the same distance within a single room remembered it just fine. People who carried that same object through a doorway into a new room forgot it far more often and forgot it faster. The doorway wasn't incidental to the forgetting. The doorway was the cause of it. But that's only half the story. A hallway in a headset is one thing. Real walls are another. So Radvansky's team rebuilt the whole setup using an actual room, an actual table, and objects people physically picked up in their own hands. Same result almost to the decimal point. Walking through a real door with a real object in your grip produced the same collapse in memory that the simulation had. This wasn't a trick of virtual reality. It was happening in real bodies, moving through real space, carrying real things. Then something strange happened. Researchers sent people looping through several doorways in a row until they ended up standing back in the exact room where they'd started. If the room itself were the container for the memory, walking back into it should have brought the memory back. It didn't. The memory stayed exactly as degraded as it had been the moment they'd left. The room was never the file cabinet. The doorway was. Radvansky pushed the finding one step further with his colleague David Copeland, and this is where it stops being about doorways at all and starts being about attachment. They ran people through the same setup, but split the objects into 2 categories. Things a person was physically carrying with them, and things they'd already set down on a table before walking through. The dissociated objects, the ones already set down, were harder to recall overall, but the carried objects took the bigger hit, specifically from crossing the doorway. The thing in your hand is exactly the thing you'd expect a boundary-triggered filing system to protect. Instead, it's the thing that gets hit hardest because your brain isn't asking what you're holding, it's asking what event you're currently in, and the object in your hand doesn't get a pass just because it made the trip with you. Not every attempt to reproduce this held up cleanly, which is exactly what you'd want from real science instead of a viral claim. A team led by psychologist Jonathan McFadyen ran a multimodal version of the experiment, combining behavioral testing with physiological measures, and found the effect was smaller and patchier than the original headlines suggested. Sometimes it showed up strongly. Sometimes it barely showed up at all. That inconsistency isn't a reason to throw the finding out. It's a clue about what the effect actually is. If crossing a doorway reliably erased memory the way flipping a switch cuts power, it would show up identically every time, in every lab, at full strength. It doesn't, because it was never a switch. It's a prioritization system, weighing how relevant an old thought still seems against how urgent the new environment appears, and that calculation comes out differently depending on how much attention the new room actually demands. A quiet walk into an empty kitchen barely taxes it. A sudden change in circumstance, a new person in the room, an unexpected sound taxes it heavily, and the more it's taxed, the more ruthlessly the old file gets discarded to make room. The doorway isn't a wall, it's a fork, and how sharply it forks depends on what's waiting on the other side. And here's the part nobody talks about. For most of the time this research has existed in public conversation, people have treated the doorway effect as a punchline about how bad human memory is. A glitch. Proof that attention leaks the second something mildly interrupts it. Evidence. If you're feeling less charitable about yourself, that you're getting older, or scattered, or simply not as sharp as you used to be, something to laugh about on a bad week and immediately forget. Appropriately enough. But that reading was wrong. What Radvansky was actually documenting wasn't a defect, it was architecture. The same mechanism, event segmentation, is what lets you watch a film and instantly know one scene has ended and another has begun, with no title card telling you so. Your brain constantly decides where one chunk of experience stops and the next starts, leaning on the environment to make that call. New space signals, new event. New event means new priorities load in, and the old ones get archived, not because they stopped mattering, but because the system already moved on. Push that mechanism back across the roughly 300,000 years Homo sapiens has existed, and it stops looking like an office inconvenience and starts looking like inheritance. For nearly all of that span, people moved through unmapped terrain, where stepping past a ridgeline or the mouth of a cave into space you hadn't assessed was precisely the moment to stop rehearsing the last thought and start scanning the new one for a predator, a rival group, water, shelter. A mind that dragged old context across that boundary was a half-second slower to notice the thing that could kill it. A mind that slammed the old file shut the instant the environment changed was faster. Faster stayed alive. Not a grudge against finishing thoughts. Closer to the opposite, they lived in shelters with one entrance, no hallway, no second room to lose a thought crossing into. A cave doesn't have a doorway effect. It has an outside and an inside, and that transition was worth every ounce of attention available. The system that erases your grocery list today was built by a species that mostly didn't have doorways at all, only the one boundary that actually mattered. Here's where it gets genuinely strange, though, because the story doesn't end with a clean case of boundaries erase. A study from Radvansky's own lab, published in Memory and Cognition in early 2026, found that event boundaries don't only delete. Information encoded right at the edge of a transition, right before stepping through or right after, sometimes gets remembered more sharply than information from the calm middle of an episode. The boundary isn't only a shredder. It behaves more like a filing clerk, one that discards some material on the way through and deliberately flags other material as worth keeping, depending on what it is and exactly when it landed. Now here's the part that should sit with you. This isn't a story about doorways, it's a story about boundaries, and you cross dozens of them a day without noticing one. Switching browser tabs is a boundary. Closing one app and opening another is a boundary. Your brain treats each almost exactly like walking through a physical door. Closing the folder for what you were just doing, opening a new one for what's in front of you now, and quietly discarding whatever wasn't important enough to survive the switch. That sentence you were halfway through composing before you tabbed over to check a message. Gone for the identical reason your reason for walking into the kitchen is gone. There's a second place you've already lived this, whether or not you had a name for it. When you walk back to the room where the thought first occurred, and it suddenly comes back, that isn't willpower. You're recreating the physical conditions that were present when the original file was open, and your brain uses that reconstruction to partially reopen it. You're not remembering harder. You're recrossing the boundary you left through from the other side. None of this required a species with hallways to evolve in the first place. and none of it required you to be tired, distracted, or getting older, which makes it a strange thing to sit with the next time a thought disappears crossing your own living room. You are not glitching. You are running hardware tuned for a world of single rooms and single exits, dropped into a species that built doorways into everything and then acted surprised when the doorways did precisely what they were built to trigger. You didn't lose the thought. You closed the door on it,